Periodic table. Atomic number, number of protons. Atomic symbol, notation for an element. Atomic mass, number of protons and neutrons. Atomic number is basically this number on the top. Atomic symbol is the letter or the abbreviation for the element. Atomic mass is at the bottom here. It's the number of protons and neutrons. Now let's talk about ions. Ions is any atom that has gained or lost electrons. So ion is when an atom steals another electron from another atom. It's not share. They're not sharing. They're stealing, okay? They're the bad guys. Cation, positively charged ions. Anion, negatively charged ions. Cation is when the atom loses that electron. So then if you remove the bad stuff, you get more positive, right? Anion is when they take in those negative electrons and they become more negative. For example, aluminum atom has an atomic number of 13, a mass of 27, proton number 13, neutron 14, electron 13. This is a cation since it's losing the 3 electrons. I didn't do a diagram because it's too much work. You can just give it a try. Aluminum ion, see? There's a difference in the number of electrons. Since it have lost 3 electrons, it becomes positively charged and it becomes Al plus 3. The atomic number is normally at the top. It's a smaller number. The atomic symbol is basically used to identify the element internationally. So in any country, they would use this symbol. No matter what language you study, it's going to be the same. Number 3, name of the element. Yeah, as it says, the name of the element. Atomic mass, number of proton and neutron. And if you want to remember where the atomic mass is, you think about the weight scale. When you stand on a weight scale, normally it's on the floor, it's at the bottom. So you would remember it as atomic mass. Sometimes the atomic mass is put in the top. In this case, you just look for the larger number. The larger number is the atomic mass. Metals, nonmetals, and metalloids. Metals are malleable, shiny conductors, high melting point. Nonmetals are dull, easily broken. They're the opposite of metals, basically. Porous conductors, low melting point, normally at gas room temperature. Metalloids, low elasticity, brittle, average conductor, look similar to metals, chemical properties similar to non-metals. Metals are at the left side of the periodic table. Non-metals are on the far right side of the periodic table, and metalloids are on the right side, but like in the middle here. Groups, vertical rows in the periodic table. Period, horizontal rows. Octet, full 8 electrons in the valence shell. Every element want to have an octet. They want to have that full 8 outside in the outermost shell. So they would either lose, gain electrons to get to that point. Well, there are also some elements that already have the 8 electrons in the outside. So they would just stay the same and stay non-reactive most of the time. Metals, materials with shiny appearance, high conductivity and high melting point. Non-metals, materials with dull appearance, low conductivity and low melting point. Metalloids, a metal with property that is between a metal and a non-metal. It means that it has some property of metals and some property of non-metals. How are the elements organized on the periodic table? In order of increasing atomic number. What do elements within the same group have in common? Same chemical property. For example, in group 1, you have lithium and potassium. They're in the alkaline metals. Alkaline metals are characterized by shiny, soft, very reactive. So all of the elements here are somewhere between shiny, soft, and reactive. What do elements in the same period have in common? Same number of shells. Group 1, alkaline metals, number of valence electrons 1. Property, reactive, not very dense, kind of soft, silvery color. Group 2, earth metals, number of valence electrons too. Some are reactive, silver and shiny, but this one is hard. This one, alkaline metals are soft, while earth metals are harder. Group 17, the halogens, 7 valence electrons, they are nonmetals, and very active, high electronegativity. What do I mean by high electronegativity? High electronegativity is how much the atom wants to steal or want to get more electrons. Since they only need one more, they just need that one more electron, they will be really reactive to get that one electron. Compared to the alkaline metals, they have very low electronegativity. They don't want to get any more, they just want to lose that electron so that they can fulfill the octet rule. Periodic table. Let's see the trend of atomic radius and ionization energy. Atomic radius increases as you go down the periodic table and increases from left to right. So let's explain why it increases as you go down the periodic table. As you go down, there are more shells. The shells increases. So in turn, the distance, the atomic radius, increases. And why does it increase from right to left? In this area, the halogens and noble gases, they have more electrons. If they have more electrons in the outer shell, that means they would have more protons in here, since an atom has the same number of proton and electron. So that means there will be more proton attracting these valence electrons and pulling them closer to the nucleus. So that means they will have a shorter distance. Compared to the first group, they only have literally like one electron in the outermost shell. And that means they have fewer protons, so the electrons will be further away from them, increasing the atomic radius. Ionization energy. The amount of energy required to remove an electron. Why do you need more energy to remove an electron as you go up here? Well, since there are less shell when you go up here, the electron will be closer to the proton, the nucleus, so that it will be harder since the extraction is stronger. When you go down here, there will be more shells, so it will be further away from the center, less attraction between them, so easier to remove the electron, to get rid of it. And down here, it increases as you go from left to right. Well, because there's more electrons in the outermost shell, there will be a stronger attraction between the center, the nucleus, and the outer shell. So they would want to keep that electron more, therefore increasing the ionization energy. This is the periodic table, and I color-coded it. It's not very fancy looking. I recommend you to go on the periodic table website. You just search up periodic table, it'll come up like the first thing. Electronegativity is the tendency of an electron to attract atoms. How much they want to take electrons from another atom. The electronegativity increases as you go from left to right. Here, the atoms, they're so much closer to the perfect octet. They would want to attract atoms to get to that perfect 8. So that's why the electronegativity increases as you go this way.